Guys, welcome back to a new day. So we're going to go into top interview questions again, but just before we do, I feel like it'd be a good time to go back and revisit some old questions that we've been doing. So on my list, I have LRU cache, threesome, and set matrix 0. So let's go back and let's try those. Let's try resolve these questions with it in my mind such that I can remember. So LRU cache is a design structure that follows a LRU cache, least reusable cache. It follows a FIFO principles, such that well, first in, last out, last in, first out. No, first in, first out. Yeah. Well, I guess more of, I guess not really. Yeah, so it's quite not the same actually. FIFA would be first in, first out always, but an LRU cache is least recently used. So if the cache is full and we try to insert something new, we have to remove the least recently used object. So we can use this using an O1, insert an O1 lookup time using a wlist link and a dictionary. So let's get into it. First we need to define our node. It's going to have a value just because it's a key in an int. I'm going to initialize it, not an int, val. And because it is a w-linked list, we will be pointing towards, we will point forwards and we will point backwards as well. Cool, now that is for a node. Let's create our actual cache. So first, the most important part is our capacity. And so capacity, and our cache is going to be a dictionary. We do this so that we can ensure O1 lookup and O1 insertion times deletion as well. We're going to be creating two dummy nodes. So how it works is the tail, and then it's going to be the least recently used element, and then some others, and then the most recently used element, followed by the head. In order to do this, we do need some dummy nodes. None. Self.head equals node, none, none. And because when the first cache gets enlarged, there will be nothing inside of it, so we'll just have to initialize the nodes such as so. Cool. Before we get into implementing the actual get input elements, we're going to define a insert to front method. We're going to be taking in a node for this. As we said above, how the insert to front. So first we need the current head, which is going to be prev, and then the current head is now going to point towards our node, and our node's previous point is going to point towards the current head. More than that, the node's next is going to point towards the head of the entire cache, and the previous of our head is going to point towards our node. Similarly, let's try to remove. We're going to remove a specific node from wherever it is within our cache. So we have our node in there. We need to grab the previous node from the node, because what removing a node really looks like is making sure that the previous node points toward the next node, and the next node points towards the previous node. So prev node point towards our node. The node's prev is going to point towards the previous node. Oops, not the node, but rather the next node. Cool. And then we do one more where it's going to be pop LRU, least recently used, and this will not take in a node. We set the last remove, the node to remove at the end is going to be the one right next to our tail. So similar to what our remove is. Yeah, and then we can simply, we can just simply call the remove function that we have defined. One more thing that we might be good to do here is to remove the actual So let's do our first put one. So, so first we want to actually create the node. And then we want to insert the node to the front. And then we want to make sure that our dictionary has a reference to this. But one important part to note here is that what if the key already exists in the cache? Then what we can do is actually we can remove this. We can remove this oops. We can remove this node from our linked, and we also have to remove it from our. After we remove it, what if we check that the length of our cache is actually bigger than our capacity? And we can simply pop LRU. So that should be our put done. What about our get? So if key not in self.cache, we're going to return -1. Else, this means that the key does exist. So we'll first get the node in question. And then we do have to return the value. But first, we want to put it at the front of the list again. So we remove this node. And we can actually insert to front node. Cool. There we go. Yeah. Yeah. Cool. There we go. Cool, cool. There we go. So that's for LRU cache. Then let's try to do 3sum. So in order to actually do this, we do need to sort the numbers. So we do need to sort our numbers first. We're going to enumerate through our numbers. Cool. Now, if the number is actually bigger than 0, we know this. This is never going to be true. So we're just going to break at that point. Return our output at the end. Now we can start off with our left and right pointers, where our left is going to equal to I plus 1, and our r is going to be the length of nums minus 1. Now, while left is strictly, we don't need that then, strictly less than r, we can find the summation. It's going to be nums of num plus nums of L plus nums of R. If summation is greater than 0, do it like this actually. It's greater than R, that means our R value is 2 less. If it's smaller than R, we can find like this. This summation is 0. So we can append this. We can append I. What are we appending? The actual numbers, right? We're actually at the actual numbers. Now the important thing here to check one more thing is that if nums L equals to nums of L plus 1, we just simply, because if you think of it such as, it's like this, right? We don't want, there's two cases which are negative 1, 0, and 1, negative 1, 0, and 1. If this, we'll add it, but then this will add it again, but we don't want that to happen here. Okay, I guess a better example might be this one. So 1, 2, 3, added it, and then this will be the same, so it'll get added, so we want to avoid that situation. And just similar to the thing we talked about before, if I is greater than 0, and I is and then this number is the same as I is minus 1, we can simply continue and ignore this I value. Oops, it's not sort, it is sort. Oops. Okay, it looks like we have a problem somewhere. It's probably, just think about it for this case. It's negative 4, negative 1, negative 1, 0, 1, 2. So we're going to be here, it skips that, so we get here. Actually, I don't even know where it skips, but okay. There should be one right, yeah. We actually don't have a, if none of that is true, we don't actually update it down here. Cool. Okay, let's see the problem here. So negative 1, negative 1, 0, 1. Why are we outputting a nothing array? I don't know if this is while it's the right one actually. Might be a if. Oh no, we're only going to append if it goes up by 1. cool. There we go. So that's 3 sum done. The next question is reset matrix. Set matrix 0. So an interesting one for this is we're going to be using the rows and indices, rows and columns as an indicator to why if we should set this row to 0. Now the only problem that might show up is with the top left. So example, if this is a row, this means this whole row should be 0. This 0, this whole row is 0. This 0, this column 0 is 0, this 0. But the problem is the top left square here. If this is 0, do we set the row, this row to 0? Do we set the column to 0 or do we set the row to 0? So for this specific case, we'll be just using a indicator, where if the indicator is true, that means set this column to 0. Whereas if we would use this 0 as an indicator to set the column to the row is 0. So first column 0. And then initially it's going to be false. Yep, so first we need to find out the length of the rows, how many rows there are, and how many columns there are within the matrix. For I in range n, so let's traverse through each. Well, we have to traverse through every block in our array. Now for our first check, if actually before we do that, we did say that we're going to check our first line, right? So we're going to check if matrix n, no. So if any point, any first column, right? First column, this is row 0, column n, right? This is the row, right? Row, that's the, yeah, that's right. If any, it's kind of weird, but if any row is 0, so if any row is 0, right? But there's X amount of rows. Yeah, this is right, yeah. So we're going to set column 0 to true. And that means for this we actually have to skip over. We have to skip over 1 to 5 for range. Yeah. Now let's check it. If this is 0, that means we're going to set the 0th row to 0. We're going to be setting the first column. This looks weird. No, yeah, this should be row. Yeah, so set the first column of this row to 0. 3. Yeah, cool. That sounds good. Yeah, there we go. Now that we've done that, we're actually going to work in reverse order. We have to work from the backwards because if we do in first order, it might poison our future. A good example, if this is set to 0, so we'll set this row to 0. And if that's the case, this will be set 0. And then the next we'll check this, and they will think, oh no, this column should be 0, which is not true. So in order to, yeah, we're going to be working in a backwards manner. So we'll start from n, we'll go to -1, and then we'll go down in steps of 1, -1. For j in range, we're going to start at m, and then we're going to go to 0 because we don't want to be, we will be manually updating the first column ourselves. So let's do the one first. If first column 0 is true, that means we're going to set the first of whatever, whoops, of whatever, yeah, right, to 0. So row, let's say it's 3. 3, yeah, 0 to 0, cool. Now let's do it for this. Let's so if the row, oh, there we go. So if the 0, whereas if matrix or if the column is 0, going to be setting it to 0. Okay, wait, let's actually think about this. So n is the amount of rows, and m is the amount of columns, rows, columns. So it's going to be 0. Yeah, 0, this is 0, set to 0, this set to 0, set to 0. Then I'm going to check the first instance of it. So for the row, so if I do matrix 2, 3, what does that mean? Matrix 0, 1, 2, 1, 2, 3, right here, right? So if row I, 0th column is 0, or if row 0, jth column is 0. There we go. Yeah, we gotta change these, the starting boundaries, because these are one too high. Yeah. But either way, we got it wrong. So let's see what the fault might be in here. 1315. Put, let's draw it out. But we outputted, but we should have outputted. Okay, it just looks like it's a indice problem. Yeah. So we did the first row correct. The second row is not correct. We just didn't update this properly because we need to update. Yeah, that's what we need to update. We've been updating the column rather than the row. Okay. So the problem was, yeah. What was I doing? I was doing the 0th row, ith row, but in the column section. Yikes. Anyways, that is our answer for set matrix stars.